Hi, in this video we're going to show you how to set up a vehicle for the traffic system. Now navigate to the model you want to use and drop it into the scene. Alright, we have a model with separate wheels and that's pretty much it. So as long as you've got that, we can start putting it together. Click on the route again, add a traffic system vehicle script to that route, and I'll run through the values of each of the items in the script. So next node, this is the node that the car is going to be trying to get to. The spawners that we discussed previously in videos, these set the next node automatically when the car spawns. Otherwise you can set it manually yourself. Just grab a node, drop it into the next node section, and the car will first go to that node and then continue driving along. So the next node threshold is how far away the vehicle needs to get from the center of the node before it tries to look for another node. Generally one's pretty good, you won't need to change that. The rotation speed is how quickly the car rotates towards the node it's trying to get to. The offset position you'll probably want to use. This basically offsets the car's pivot point from the node it's trying to get to. So you notice this pivot point is actually higher than this pivot point, and we want to make that offset so the car doesn't end up always trying to get to this position here. Let's offset that by about 0.5. 0.48 should do. Right, that should be good. Vehicle minimum velocity and maximum velocity can be set so the car won't go any slower or any faster than that. And the velocity itself will show up here, and the original velocity will show up here. You don't need to change these. The acceleration rate and deceleration rate will force the car to go faster or slower when accelerating and decelerating. The random lane change means that when you're on a highway, this is the percentage chance of the car actually changing into either lane going in the same direction. You can set that to however you want. If you don't want it to change lanes at all, set it down to 0 and it'll stay in the same lane. Chance of using the off-ramp, same thing. There's a percentage chance of it using an off-ramp if it comes up to an off-ramp. And the chance of a direction change is used at intersections and T-junctions where there's a percentage chance of it actually going around a corner or changing direction this way instead of always going straight. So you can set that as well. Each car needs a rigid body, so we'll add that now. Rigid body. And we'll turn off gravity because we don't want to use gravity, and we'll drop the rigid body on there. Each car also needs a collider, so we'll add that as well. It can be a box collider, it can be whatever collider you want as long as it suits the shape of your car, and we'll also add that as well, and we'll line this up. Yep, good enough. Make it a little bit smaller. Okay, moving on, we have rear lights. We will steal them from the already made prefab. Rear lights, blinkers, we'll grab all them and put it in there. Yeah, we don't really need him anymore. Okay, so let's just position our rear lights here. It's fairly rough, but you get the idea. And we also want to put our front blinkers on. And our rear blinkers on. Now these are just transforms, so you can add all kinds of different effects to your blinkers and your lights. They can have, you know, real point lights or different kinds of things that all just sit under the one transform, because all they do is get turned on and off. Okay, let's turn our rear lights off. Don't need them. These will also get turned off when the car starts, so no need to turn them on or off. Right, rear lights, we add them in. We also add our blinkers in, so they're the right blinkers. And we add the left blinkers in. Left blinkers, let's just check that we actually have them on the left and right sides. Yep, they're correct. Right's over there, okay. And then we add the blinker speed, so how quickly they'll flash, you can change that. We want to add our wheels in so they start to rotate, so we want front wheels in here, front, left, front, right, rear, left, and rear, right. So that's the wheels put in. The wheel axis, this is where which axis it's going to spin on. Generally, just click on it and find the axis that goes across this way. That's the x-axis currently for this object, so we'll leave it at x. The wheel check, the vehicle check distance. Now this is this little sphere here where it gets positioned. As soon as another vehicle hits this, it determines whether the car should stop or not. So you probably want to put that around the front of the car and increase the radius just so it gets outside the car or the collision box as well. That's pretty good. You can enable another check as well, which can help avoid other cars, and you can put this at the back or the middle. Generally for trucks and bigger vehicles you can add that in, but we won't be using that one. Then you've got the intersection check distance ray. This is the yellow line here. This can be adjusted to whatever length you want, but it's generally a good rule of thumb to make sure that this point here is going to, let's just move the car up, is going to sit through the intersection and also nearly another car's length, so that the car knows if there is a blockage over here, it doesn't need to go anywhere. Furthermore, that's the simplest check you can do at the intersection. The next check you can do is a capsule check, and it's probably best to keep this one on. We'll get down to the detection in a minute, but unfortunately we haven't been able to visualize this yet. We'll probably get that in the system soon, but the way it works is it's the radius of the capsule. So if you can imagine the capsule being kind of a long tablet looking shape, the radius of that is the width of your vehicle, and it's roughly around the same width as the radius of the sphere, so you can get your judgment from that. And then the vehicle check distance is going to be how long the capsule is from the pivot point. So we're looking at around about the value 6, which seems to work well for this particular car and this particular scaling of traffic. So try and keep that scale to however large you scale your road pieces. So 6 by 1 it currently is at the moment, but if you scale your road pieces by 2 it'll be 12, and so on and so forth. But we'll get some visualization in for that. The other way of testing it is to obviously set the value, get the traffic system and vehicles in place at the lights and see what happens. But right now that's probably your best bet for checking things at traffic, because it does the width instead of just doing one ray trace, which is that tiny little line. There's a minimum wait time and a maximum wait time once a vehicle does come in contact with another vehicle. If you don't want them to wait at all, which we generally don't, we'll just set it to 0 and they go straight away again when they can. Otherwise they sit there and wait. After that random time's been picked, it then decides to move again. Also, if the vehicle gets stuck for any reason at all, after this time frame, which we've set to 40 seconds, the vehicle will be destroyed and therefore allowing the traffic to move again. And then now we're to the traffic light detection. What you can do is you can set it to none and it won't use anything at all to detect if other vehicles are in the way, and as soon as the light turns green, off it'll go. It's not the best detection, but if that's what you need, then it'll definitely do that. The ray trace just uses the thin line you see here, which is less of a performance hit than the rest of it, but it's not too bad whichever option you choose to use. So you can use the capsule option only as well, but we just stick to ray and capsule together, and that gives the best outcome. So to prove that it works, let's go and put a node piece on the next node to go to. Let's select this one. And we're going to go to that node. Just double check that's the one. And our vehicle, you'll see in action. There he goes. Stopping. As you can see, the offset is a little bit off. So you just need to tweak that to make sure that it's correct. And that's it working.